This is Dr. Emmanuel, and I want us to do a very quick revision on the motor and sensory areas of the cerebral cortex. As we can see on this image, this is a very colorful pictorial representation of both the motor and the sensory areas of the cerebral hemisphere. So let's start with the most prominent ones. We have the primary motor cortex, which is responsible for movement of our upper and lower limbs, movement of the muscles of our trunk, and many other muscles in the body. So the primary motor cortex is in the precentral gyrus, as we can see. So it's precentral because it's just in front of the central sulcus of Rolando. Okay, we saw that in one of our previous videos on the morphology or the architecture of the cerebral hemisphere. So the primary motor cortex, which is Brodmann area 4, is in the precentral gyrus. And we can see just adjacent to the primary motor cortex is the secondary motor. So we have the primary and we have the secondary, or we call it the somatic motor association cortex, okay, in the premotor cortex. So this is the premotor. So this is a motor and this is the premotor. It's association, which means it's supporting the primary motor cortex. Primary motor means most of the nuclei responsible for movements are found within this precentral gyrus. So most of them, the large nuclei, are found here. But then there are other nuclei that support the whole process of movement or motion that are also found within this association area. So the motor association area, somatic motor association area, is here. Okay. So precentral, front of the central, central sulcus. Behind the central sulcus is the postcentral gyrus, and that subserves the primary sensory cortex. So most of the nuclei responsible for sensation are found within this postcentral gyrus, okay? And that's why it is the primary sensory cortex. And you can see adjacent to it, just behind to it, is the sensory association area, somatic sensory association area. Somatic is there because it's for the somatic part of the body, okay? Your limbs, your head and neck, and your trunk. So somatic sensory association area is just behind the postcentral gyrus. And in the occipital lobe, we can see we have our visual area, and we have our calcarine sulcus, just somewhere here. So that's the calcarine sulcus, and the calcarine sulcus is more prominent on the medial surface of the brain. Okay, but it extends laterally on the occipital lobe. So that's the visual cortex. And you can see adjacent to the visual cortex is the visual association area. Okay, just behind, just in front of it, rather, is the visual association area. On the superior gyrus of the temporal lobe, we can see we have the auditory cortex, which is responsible for hearing. So this is the primary auditory cortex in the superior gyrus of the temporal lobe, and just around that is the auditory association area. So you can see that the association areas are just adjacent to the primary motor or primary sensory areas of the cortex. Not labeled here, but in the inferior frontal gyrus, somewhere here, in the prefrontal cortex, somewhere here, in the, not in the prefrontal, in the frontal cortex, but the inferior lobe, inferior gyrus, is the Broca speech area, which is the primary speech area. And we'll get to see that is that's areas 44 and 45 on the Brodmann classification, okay? So this shows us the primary motor area, the primary sensory area, the primary visual cortex, the primary auditory cortex, and right here, but not labeled, is our primary speech area, okay? That's the Broca's area. So those are the main ones that, one should remember. This is another image, I think just almost similar to the previous image, but in this image, we can see the insula, okay? the island of rail is visible, and it's visible because the inferior frontal gyrus and the superior temporal gyrus have been reflected. Okay, so we can see the insula, and right in the insula, we can see the gustatory cortex. Okay, you can see the gustatory cortex. And this is, you can also see part of the olfactory cortex, but that's usually, I think that looks like it's part of the, it's close to the parahippocampal gyrus. Here again, we can see just revision because, repetition enhances memory, okay? So there's no harm in repetition. So we've seen our visual cortex, okay? We've seen our auditory cortex there and the auditory association. We've seen our primary motor. We've seen the motor association, somatic motor association area. We've seen our primary sensory area, which is postcentral gyrus. And we've seen the somatic sensory association area. This is the Brodmann's classification of these areas of the brain. And I've just picked up, the most relevant ones. There's so many of them, but I don't think, if you want to know all of them, fine, search it up. But I think the major ones are the ones that I've just picked up. So areas 1, 2, 3 are the primary sensory area, which is the postcentral gyrus. Area 4 is the primary motor cortex or area, which is the precentral gyrus. And area 17 is the primary visual area, okay, at the calcarine sulcus. Areas 41 and 42 are the primary auditory cortex, and areas 44 and 45 are the primary speech area, which is the Broca's speech area. This image illustrates the Brodmann's, classification, Brodmann areas, and just as we've said, area 4 is for motor, areas 1, 2, 3 is for the primary sensory, and areas 44 and 45 are for Brodmann's speech area, motor, which is the motor aspect for speech. Area 41 for auditory, areas 41 and 42, and let's say area 17 is for the primary visual area. This is a medial section of the cerebral hemisphere. Previous sections we've seen are lateral views. This is the medial view, or the median view that shows us some other areas of the brain. So right there, we can see our more prominent calcarine sulcus. So that's the visual area. Okay, so visual area. Okay, and of course the visual association area responsible for sight, image perception, image recognition. We have our primary motor area. So this is just the extension. Most of it is in the lateral view, where it just extends. The precentral gyrus extends. So that's the primary motor area. Behind it, in our postcentral gyrus, is our sensory area for sensation from muscles and skin. And right behind is the sensory association area. Okay, yeah, and right in front of this is the motor association area. Okay, and this is the cingulate gyrus, which plays a role in emotional area, or in regulation of emotions, pain, hunger, fight and flight response. Okay, that's the cingulate gyrus. And this is our olfactory area, which we saw that olfactory area when this superior temporal gyrus was reflected. Okay, so for smell, olfaction. So olfaction means smell, and the olfactory area is right there. And that is the uncus, okay? So this is part of the parahippocampus gyrus, and that is the uncus, which is the terminal, portion of the parahippocampal gyrus, also called hippocampal gyrus, okay? Yeah, and hippocampal gyrus, we were told, also plays a role in emotional control. And that's why when there are problems in the uncus and the parahippocampal gyrus, you can also have some psychiatric conditions. This is our prefrontal cortex, which is responsible for higher mental functions like concentration, planning, judgment, creativity, inhibition, and expression. Okay, the prefrontal cortex. We move to a previous image, we'll see it was clearly written there. Okay, so that's the prefrontal cortex. Let's go ahead. This is a repetition just to buttress the memory. So this shows the medial surface of the brain again. That's our cingulate gyrus there. And this is just our white matter commissure, okay? That's the phonics, and that's our olfactory bulb, olfactory tract, and that's the uncus. And that's our primary motor cortex, okay? So the uncus is part of the primary motor cortex. That's our primary motor area. That's our motor association area. That's our primary sensory. That's our central sulcus, sorry. So that's our primary motor association, primary sensory association. This is primary visual, and then visual association area, okay? Yeah. And this is an image of what is called the homunculus. So the homunculus is a diagrammatic representation of how different parts of the body are represented on the cerebral hemisphere. We can see the body is represented in an upside down fashion. So the body is represented in an upside down fashion. We have the lower limbs on the medial parts of the frontal cortex, okay? And we have the rest of the body on the lateral surface of the brain. And you can see the genitals are right there. So what this thing means is if you understand the representation of the body on the cerebral hemispheres, then you can understand what parts of the body or what parts of the brain, what functions of the brain become affected when you have, occlusions of several cerebral arteries. Most of the lateral surface of the cerebral hemisphere is supplied by the middle meningeal artery. So if you have a stroke of the middle meningeal artery, you could expect that the upper limbs, head and neck will likely be affected. So the speech, okay, and then your upper limbs could be affected. Most of the medial surface of the cerebral hemisphere are supplied by the anterior cerebral artery. So if you have an anterior cerebral artery ischemia or occlusion, then you can have lower limb weakness. And this is just a pictorial representation of the blood supply to the cerebral hemisphere. So you can see that most of the lateral surface of the cerebral hemisphere is supplied by the middle meningeal artery, okay? Most of the occipital is supplied by your posterior cerebral. When you look at this other area, that most of the medial surface is supplied by the anterior cerebral artery. So this gives you a clue. So understanding this image and then merging it with an understanding of the homunculus can give you an insight into what parts of the body or what functions of the brain could be lost when several arteries become occluded. So if the posterior cerebral artery becomes occluded, because it supplies the occipital lobe and it supplies the visual area, there could be loss of vision. Okay, the occipit is posterior, so it could also affect your olfaction, your smell. Okay, middle cerebral could also affect your sense of smell. Anterior cerebral can affect your motor function, okay? Mostly the lower limb, because it's the lower limb that's usually represented on the medial side of the primary motor cortex, and even, loss of sensation in the lower limb. But then when you move this way, middle cerebral will affect. So it can give you paralysis in the upper limb, paralysis in your head and neck muscles, difficulty in swallowing, okay, speech problems, arm weakness or arm, paralysis. Same thing with the sensory aspects, okay? Yeah. And then still middle cerebral could affect your speech because your broca speech area is right there in the inferior frontal gyrus, okay? So you can have aphasia or dysphasias. So this gives you an understanding of the various areas or cortices of the brain and what functions are likely to be lost when you have several forms of ischemic or hemorrhagic strokes. So we've come to the end of this revision. I hope it was helpful. Kindly like, share with your friends, and subscribe for more videos to come. Thank you.